All right, so this is the last type of equation that we're going to solve for Unit A. So this is the 5th day, and we are going to solve radical equations today. So one thing to keep in mind is that radical equations can have extraneous solutions. So we're going to make sure that we check for extraneous solutions. So the types of equations that we're checking for extraneous solutions are the rational equations, the ones that have the fractions, the absolute value equations, and now the radical equations. So for our first example, we're just going to solve. And our example is the cube root of 4x minus 6 on the outside of the root equals 0. So this is an example of a radical equation because it has a radical. So we can have different types of roots. We can have square roots, cube roots, fourth roots. So we're just going to logically go through the process of solving this for x. So hopefully, you guys, the first thing you guys would think to do, which is to go ahead and move that 6 over. And then if we want to get rid of a cube root, you're going to cube both sides. A cube gets rid of a cube root, and it just cancels out, and we're left with 4x. And then on the right, we need to cube 6, and we're going to get 216. All right, and then finally, to solve that for x, we just divide by 4, and we get that x is 54. All right, so you guys take a second and check that. So plug it back into the original problem. And make sure it works out that you end up with 0. All right, so you do. Underneath that cube root, you get 216. And the cube root of 16 is 6. And obviously, 6 minus 6 is 0. So x is going to be equal to 54. All right, the next one we're going to do is a big step up from that one. So for b, our equation is the negative square root of 40 minus 9x plus 2 equals x. Okay, so eventually we are going to have to square both sides to get rid of the square root, but we're nowhere close to ready to do that yet. So before you do that step, you always want to isolate the radical. All right, so we'll start off by moving the 2 over with the x. All right, and then we're still not ready to square both sides. We need to get rid of that negative that's in front of the radical. We cannot distribute it inside of the radical, so what we'll do is just divide through by -1. It doesn't affect what's inside the radical. Now, I hope it doesn't freak you out, but I'm going to switch the order a little bit. So I know when I do -2 divided by -1, that's +2, and then x divided by -1 is minus x. Okay, and now the radical is isolated. We're ready to square both sides. All right, and it's super important that you understand that 2 minus x must be squared as a quantity. All right, so on the left side, it's no big deal. The square just gets rid of the square root. But on the right side, I need to square 2 minus x as a quantity. So I have two options. I can take 2 minus x and multiply it by itself and distribute the 2 and then distribute the negative x. That's perfectly fine. However, there is a faster way, and I would like for you guys to use this method anytime you're squaring a binomial. So it's inside the parentheses, there's two terms separated by addition or subtraction. There's a shortcut to square it where you square the first term, you multiply the terms together and multiply by 2, and then square the second one. So that's how I will square binomials throughout the year, and I hope you will as well, because it will definitely save you some time on things like the ACT. So anyway, we'll start with this one. We're going to square the first term, which is 2, so it's going to be 4. Multiply these together, get negative 2x, and then multiply by 2 is negative 4x. And then square the second term. So that is always going to be a plus, because when you square a negative, you get a positive. When you square a positive, you get a positive. So it should equal x squared. Okay, so we don't have a radical equation anymore, but we have a quadratic equation. So to solve a quadratic equation, most of the time, we're going to get everything on one side and see if it will factor. So I'm just going to move everything to the right side. So I'll add the 9x to the negative 4x. I'll subtract 40. All right, and then I'm going to write this in descending order or standard form. So the x squared is first. All right, then we have plus 5x plus 30 minus 36. Okay, so then we'll just take a second to factor that. Okay, so now we have two answers, negative 9 and 4. But not necessarily. It's possible that one of these is extraneous, or it's possible they're both extraneous. And the only way to know is to go back and plug them in. So I'm going to move over. I'm going to take both of these and put them in for x. So we'll start with negative 9. Okay. So inside that radical, I'm going to do negative 9 times negative 9. That's going to be 81. All right, that inside is going to be 121. And then we get negative 11 plus 2 equals negative 9, which is true. So negative 9 is the solution. All right, and then we'll take a second to check 4. So negative square root 40 minus 9 times 4 plus 2 equals 4. Okay, So same thing, just go start simplifying it down. So I get -2 plus 2 equals 4, which is not true. 0 does not equal 4. So 4 was an extraneous solution. So what you would do is just go back, just mark it out. Okay, so that was a lot, a lot of steps. All right, we're going to do one more. So this one, we have the square root of x plus 1 minus the square root of x minus 6 equals 1. Okay, so when we have two radicals on one side added or subtracted to each other, it's easier to do this problem if you get one radical on each side. So we're going to rewrite with one radical on each side. Okay, so it'll be easier to move the one over that's negative. Okay, so we're ready to square both sides. Right, when we, on the left, it's not as difficult. We square a square root and we are just left with the x plus 1. On the right, we have to square this as a quantity. So I'm going to use my good old fashioned rule shortcut to be able to do this. So I'm going to square the first one, which is going to be 1. I'm going to multiply these together and multiply by 2. So that's going to be 2 square root of x minus 6. And then I'm going to square the second one. So when I square the square root of x minus 6, that just leaves you with x minus 6. So take a second and look at that. It's kind of weird. Okay, so then we're going to isolate, what we're left with is another radical equation. So we're going to isolate the radical. All right, so this is just going to take a second. So I'm going to let me just combine like terms. So I can't add this 1 and this 2 because they are not like terms. But I can add the 1 and the negative 6. Okay. I cannot combine -5 and 2 because this one is attached to a radical. So I'm going to move my x's together. So that's going to cancel out and get 0. And then add 5. It's going to be 6. It's 2 square root of x minus 6. Okay. And then divide by that 2. Okay. So finally, it takes us to one similar to what we started with on the very first one. So we can go ahead and just square both sides. And then add 6. Okay, this is maybe the answer. We won't know until we check it. So I just took 15, I put it in to the original problem. So that's going to be the square root of 16 minus the square root of 9 equals 1. So 4 minus 3 does equal 1. So 15 is a solution. So that's a lot. It's like 2 radical equations in one. But you guys can do it. All right, so here's your assignment. Still working on that page from the book.